So we will begin with the second part of our review of graphing. And our first example is that we want to graph the linear equation 2x minus y equals -4. And in order to do this, we will first make a table of values by choosing x values and y values. And very often the easiest values to choose are to let x be 0 and to let y be 0. And then since we'll need a third point, then I'm going to choose to let x be 1. So when we choose to let x be 0, we have 2 times 0 minus y equals -4. And that essentially is just -y equals -4. So to change the signs of both of these, then we would have positive y equals +4, and you can change those signs by either multiplying by -1 on both sides or by dividing by -1 on both sides. So we have the point 0, 4. Then for our second choice, we have 2x minus 0 equals -4, which of course is simply 2x equals -4. And therefore x equals -4 over 2, which is -2. So now we have 2 points. And then last, we'll choose x to be 1. And 2 times 1 is 2, minus y equals -4. If we subtract 2 from both sides, then we have -y equals -6. And as we did in our first choice, when we let x be 0, multiply both sides by -1 or divide both sides by -1, and we have that y is equal 6. So we have the 3 points, 0, 4, -2, 0, and 1, 6. So I'm going to make a note of those points. And to graph this linear equation, we're going to plot those 3 points. So 0, 4 means I go to the origin, and I don't go right or left, I simply go up 1, 2, 3, 4. And for -2, 0, I return to the origin and I go left 1, 2, and then I don't go up or down. And then for the point 1, 6, I start at the origin and go right 1, and then up 1, 2, 3, 4, 5, 6. So now that I have 3 points, I can see that they're lining up in a nice straight line. And so I'm going to graph. And of course, ideally, we would use a straight edge, but in the recording, I'm just trying to be as straight as I can. You should also label your points. You should make sure that your x and your y-axis are labeled, and sometimes if you've changed the scale to something other than each block represents 1, you might want to make a note of what the scale is by listing some tick marks. For example, here, that point would be 5, and this would be -5, and this would be 5, and here we would have -5, and that would be enough information for a person to read the graph and know that was how you were scaling your graph. And then the last thing to have a complete graph is to put your equation on your graph. So that would be a complete graph. Label your points, label your axes, label a few tick marks on the axis, and then put your equation on the graph. So now we're going to talk about how do you identify intercepts. And the way that you identify intercepts is, here we have the graph of y equals (4x minus 8). And what I'd like for you to notice is that the graph crosses the y-axis at the point 0, -8. So 0, -8 is what we call the y-intercept. Intercept means to cross. There's another word for intercept that means to cross, and it's called the intersection point. So we could also say that 0, -8 is the intersection point of y equals 4x minus 8 with the y-axis. Likewise, you should note that it crosses the x-axis at the point 2, 0. So for that reason, we say that 2, 0 is the x-intercept to indicate that that's where it crosses the x-axis. And a point to make note of here is that these are ordered pairs, which are also called points. And those ordered pairs are the intercepts. So the intercepts, properly written, are 0, -8, and 2, 0. That is the correct way to write x and y intercepts as ordered pairs. Sometimes, and this even happens with textbook authors, unfortunately, I have seen y-intercepts written as y equals -8, or as x equals +2. Neither of those is correct. Do not write intercepts as equations. An intercept is an ordered pair. It is a point. It is not an equation. The equation y equals -8 graphs as a horizontal line. So that is y equals -8. And this is x equals 2. And as you can see on the graph, both of these are straight lines. They are equations. They are not ordered pairs. Intercepts are always ordered pairs. So please keep that in mind as we proceed. So once again, Nice hint here. The graph crosses the x-axis at 2, 0. We call that the x-intercept. And when you have an x-intercept, keep in mind that your y value is 0. And when you have a y-intercept, your x value is 0. So keep in mind that for the x-intercept, it is the y that is 0, and for y-intercepts, it is the x that is 0. That sometimes confuses people. So here we're going to identify the x and the y-intercepts. We're going to begin with the x-intercepts. The x-intercept of graph A, which I'm sure you've noticed is not a straight line, it actually has two x-intercepts. The first one is at the point -1, 0. And its second x-intercept is at the point 3, 0. Graph B is a vertical line. It does cross the x-axis, and its x-intercept is at the point 2, 0. Now we'll talk about the y-intercepts. The y-intercept of graph A is at 0, -3. But we notice on graph B, which is the vertical line, that there is no y-intercept. And the reason there isn't is because on this particular line, this is actually the graph of x equals +2, and every single point on this vertical line has the x value 2. And if you remember that your y-intercept is where x equals 0, well, x is never going to be 0. X is never equal to 0. So it has no x-intercept. I'm sorry, no y-intercept. So, one final reminder, if you need to find x and y-intercepts, to find the x-intercept, you let y equal 0 and you're going to solve for x. To find the y-intercept, you're going to let x equal 0 and solve for y. And most of the time, the arithmetic to do either of those two is relatively simple. So now we're going to graph 4 equals x minus 3y by finding and plotting its intercepts. So to find the first intercept, we're going to let x equal 0, which means we have 4 equals 0 minus 3y. And if 4 equals -3y, then 4 over -3 is equal to y, which tells us that y is equal to -1 1/3. So the point that we've found here is our y-intercept, 0, -1 1/3. And that puts us about here. And then next we're going to find our x-intercept. We're going to let y be 0, which gives us 4 equals x minus 3 times 0, which is simply 4 equals x. And that gives us the point 4, 0. So we go to the origin and count right 4. And that gives us our x-intercept. And then we need to draw a straight line. And the last thing we need to do is to add our equation. 4 equals x minus 3y. And that is a complete graph, and we only had to have 2 points. So as I've mentioned once before, using x and y equals 0 is usually a fast way to get the arithmetic done, and often you won't even need a calculator to do it. Now, unfortunately, it's not always going to be that you're plotting the intercepts will lead you straight to the graph. And this is a good example of that. So here, I'm going to start off by letting y equal 0, as I did before, which means I have 2x is equal to 0. And that means then that x is 0 over 2, which is 0. So it would seem that my x-intercept is 0, 0. But the first thing you're going to notice here is not only have I found where it crosses the y-axis, I found where it crosses the x-axis, because it crosses at the origin 0, 0. So we're not going to be able to graph it strictly by plotting the intercepts. And all that means is that we'll need to choose another point or two. So I'm going to try let x, again, because I'm kind of lazy on the arithmetic, I'm going to let x be 1. 2 times 1 equals y, and since 2 times 1 is 2, then y is equal to 2, and that gives me the point 1, 2. Which is here. And it's pretty unlikely that I messed up the arithmetic, but just to be on the safe side, I'm going to choose to let x equal negative 1. That means 2 times negative 1 equals y, which means y equals negative 2. And that gives me the point negative 1, negative 2. And when I plot that point, I see that they are lining up in a straight line. So I can now draw my line. And I'll label my other 2 points. And I'll put my equation on the graph. Two x equals y. It's a really terrible equal sign. That's a little better. And if you wanted to add some tick marks, you could, but with the labeling of the points, I think that would be all right. But again, notice that anytime 0, 0 is a point on the graph, then it is both an x-intercept and a y-intercept, because it's the only point that lies on both axes. So here we have a little bit of a different case. Here we've got the graph of x equals negative 3. And what x equals negative 3 says is, I don't care what y is, x is going to be negative 3. So if y is 0, x is negative 3. And if I choose y to be -2, x is going to be -3. And if I choose y to be 4, x is -3. So there's those 3 points. And what you should notice is that those 3 points are all on the straight but vertical line which is x equals -3. So the key takeaway here is that when you have x equals whatever, that's always going to be a vertical line. And it'll cross the x-axis at whatever number that is assigned to x. But this is the case when there's no y variable. So here we have the graph of another odd line where y is equal to 3. That means if I say, okay, I'm going to find the y-intercept, let x be 0, well, this is easy. Y is equal to 3. But if I choose to let x be 4, y is equal to 3. And if I choose x to be -2, y is equal to 3. So what you notice here is that all of those points are a straight but horizontal line through the y-intercept 0, 3. So again, the takeaway here is that y equals lines are always going to be horizontal lines. And y equals whatever that number is will tell you the y-intercept. And the key is that there is no x value in the equation. There is no x variable. Now we're going to shift gears a little bit, and we're going to talk about the slope of a line. So the slope of a line, which we usually indicate as m, that contains 2 points. The first one we'll call x1, y1. And the second one we will call x2, y2, indicating that it just comes second. And the way that we find m, we have several different phrases, several different words for it. We say that it's the rise over the run. The reason we use that language is because when you're finding the slope, what you're calculating is, in the numerator, how far does it go up or down, and in the denominator, how far does it go right or left. So I don't really know that rise is the best word, because rise seems to indicate that you're always going to go up. But it is the vertical change over the horizontal change, which I like better as language. Of course, that isn't quite as catchy as rise over run. The key thing to remember is that it is the change in the y values divided by the change in the x values. And one of the things that will help you remember how to do this correctly is to remember that the coordinates of your points have to stay together. They line up over the top of each other. So there was x1, y1, and x2, y2. And then the key beyond that is just simply to remember that it's change, and change is a difference. So we're going to calculate a slope. And the way we're going to do it is we're going to use this set of points. And my first point is going to be 4, -3. So I'm going to go to the origin and count over 4 and up 3. I'm sorry, I just realized that was -3. Let's try that again. Go over 4 and down 3. And there's my first point. And then the second thing I'm going to do is I'm going to plot the point 2, 2. So that means I'm going to go right 2 and up 2 from the origin. And there's that point. And there's a line through these 2 points. And we're asked to calculate the slope of that line. Now we can calculate it using the formula, and in fact we will. But before we do that, I want to point out to you that actually once you've plotted these points, you can calculate the slope by counting. So if you start at the leftmost point, to get to the rightmost point, you're going to go down 1, 2, 3, 4, 5. And then you're going to go right 2, 1, 2. And that's going to be the slope of that line. So we actually already know that the slope, m, is equal to -5, because that was the vertical change, over 2. There's actually 2 different processes we can use to count that slope. So first I'm going to write your essentials of your slope formula, which is that it's a fraction, so draw the fraction bar. And in the numerator you'll be subtracting, and in the denominator you're going to be subtracting. So the first point, y is on top. Remember, you have to put the y value on top because it's vertical change. -3 is on top and 4 is on the bottom. That's the point 4, -3. And then the second point, and I'm going to indicate this with red to make it a little distinct, is going to be 2, 2. So x is 2 and y is 2. And when I calculate the slope this way, what I get is that the slope is equal to -3 minus 2, which is -5, over 4 minus 2, which is 2. And that's what I got by counting. But what I want you to understand is that it doesn't make any difference which point I choose to use first. I could use 2, 2 as the first point, and 4, -3 is the second point. And notice that the only difference is that I have 2 minus -3, which is 2 plus 3, which is +5, over 2 minus 4, which is -2. And -2 in the bottom doesn't change the fact that the entire slope is -4 5 over 2. So that is your slope. And if you wonder why this, does this still work? Yes, actually it does. If you go from the other point, you're going to go up 5. And left 2. So that is still the same slope. And if you go from either of these points and you go up 5, 1, 2, 3, 4, 5, and left 2, you're still going to be back on the line. Or if you go down 1, 2, 3, 4, 5, and right 2, you're still going to be on the line. So that's the reason that we have slope being what it is. It is a constant change. So what we've just seen is that when we're finding slope, it makes no difference which point is x1, y1, which is x2, y2. Just remember that whatever y value is first in the numerator, its partner x value is first in the denominator. Keep them together. Some key things to remember about slope. This line has positive slope. In other words, the value of m is greater than 0. And notice that this line, if you go from left to right, goes uphill. So it goes up to the right. Whereas the other line, which has a negative slope, as our last example did, as you go from left to right, it's going downhill. So it goes down to the right. You're always reading from the left to the right. And that leads us to the useful form of a linear equation, which is called the slope-intercept form. It is a linear equation still, which means it'll be a straight line. We will still have two variables, x and y. But in the slope-intercept form, we have y equals the slope times x plus a constant b. And the slope and the value of b both tell us some good things about the line. M is the slope, but 0b gives us the y-intercept of the line. In other words, it gives us a point on the line. So for example here, the slope of this line is 3. And since it's always a fraction, it's 3 over 1. And we also notice that the value of b is -4, so that means it's going to cross the y-axis at 0, -4. So what would happen if we were trying to graph that line? Let's suppose this is 0, -4. Then we would go up 1, 2, 3, and then right 1, and we would be able to get another point and be able to draw the line. Now that's not a very good graph, but that's kind of the gist of how we're going to use this information. So first of all, let's say we need to find the slope of the line -3x plus 2y equals 11. And then we're going to solve the equation for y. So first of all, we need to find the slope of the line. And one of the ways we can do it is by solving the equation for y. So when we do that, we have negative 3x plus 2y equals 11. And our first thing, since what we want to do is we want to isolate the y term, is we're going to add 3x to both sides. So now we have 2y equals, and just because I want the x term to come first, I'm going to say 3x plus 11, because arithmetic is commutative. And then because I need to get rid of that 2, I'm going to divide both sides, every single term, by 2. And that's going to leave me with y equals 3 over 2 times x plus 11 over 2. Or if you want to change that to 5.5 or 5.5, you can do that. And that tells me that the slope of that line is 3 over 2. Now, if I were to try a different method, what I might want to do if I were going to graph this line is I might find its intercepts. So if I let x equal 0, then that tells me that y equals 11 over 2. Which, guess what? Is the same value as b is. So that gives me the point 0, 11 over 2. And if I let y be 0, then negative 3x equals 11. And then that means that x equals 11 over negative 3. So that gives me the point 11 over negative 3, 0. And I don't need to plot those points. I can use my slope formula. So choosing the y-intercept first, 0, 11 over 2. Oh, sorry. Wrote it upside down. (11 over 2), 0. That's the first point. And then the second point has negative 11 over 3. And the y value is 0. And I'm going to subtract those. And yes, I know we're dealing with fractions. It's not fun, but you can do this on your calculator. So the slope is equal to 11 over 2 divided by positive 11 over 3. And if you divide that on your calculator, what you're going to see is that the resulting fraction is in fact 3 over 2. The same as it was before. Now, by far the easiest way to find slope, if you have the equation and not points, is actually to solve your equation for y. The key is you need to solve it for y, not negative y. So in this case, the equation negative y equals 6x minus 7, I need that to be for positive y. So in order to do that, I'm going to multiply this side by negative 1, which means I also need to multiply the other side, everything on the other side, by negative 1. So negative 1 times negative y gives me y. And negative 1 times 6x gives me negative 6x. And negative 1 times negative 7 gives me positive 7. And since 6 is an integer, I'm going to put it over a 1. So the slope is negative 6 over 1. And the y-intercept, even though it wasn't asked for, is 0, 7. Now you actually have a couple more slides on your PowerPoint, but we're not going to need the information that's on those slides, so we're not going to worry about parallel and perpendicular. This will complete your notes for the review of graphing.